All right, I'm going to have to do this one differently. I've redone this. This is the second time. I'm just going to have to rewrite everything. So first of all, we're going to start this by sketching the region. So the region's bounded by the y-axis. So the graph of y equals x squared and the line y equals 4. So here is our region. That's from 0, 0. This is 2, 4. And this is 0, 4. Now, we're going to find the area. So first of all, I'm going to redraw this. If I do cuts horizontally, I think it's a nicer integral. So my sample point is an xy. The distance from the y-axis to the point is x. So I come over here and say, listen, y squared is x. Y is x squared, so that means x is the square root of y. And that integral goes from 0 to 4, the square root of y in y. Gain of power multiplied by reciprocal from 0 to 4. That's, 2/3. 4 to the 3 halves minus 0 to the 3 halves is 0. The square root of 4 is 2. 2 cubed is 8. 8 times 2 is 16, but don't forget the thirds, and that's square units. Now, the other way I could have done this problem is I could have cut vertically. And if I do, my little rectangle looks like that. And my top function is 4, and my bottom function is y, because I'm cutting vertically in x, and x goes from 0 to 2. But what is y? Y is x squared. Now this one's not so bad, but it's not as easy as that one. So this is going to be a 4x minus a 1/3. Don't forget to cube the x like I just did, from 0 to 2. Now at 0, it's going to be 0. So this is 8 minus 8/3 minus 2 zeros. I'm going to factor this 8 out, and then you should see in your head 1 minus 1/3. But 1 minus 1/3 is 2/3, and 8 times 2/3 is 16/3 square units. Notice the answers are the same, and they should be the same because it's the same region. Because if you came up with a different answer, I would be very frightened. Now, because of this mess I've created, let me pause this for a second. Okay, so now we've done part A again. Now part B, part B isn't so bad. We're going to find the volume of the region when I revolve this around the volume of the solid when I revolve this region around the y-axis. Okay. So remember, what you're going to do is you're going to sketch what you're reflecting. Sketches don't have to be perfect. So now we're going to take a horizontal slice and I revolve it. Can you see your disc? When I pull this out, my heights are in y. So when I put my sample point here, the distance from the y-axis to here is x. So the area of this cross-section is pi x squared, but that's the radius. Hey, but isn't y equal to x squared? So this is pi y. So the volume of this slice is the area of this cross-section dy, which is pi y dy. So my volume, now remember, pi, well, and then we have a y dy, but y doesn't go from 0 to 2, it goes from 0 to 4. So pi over 2 y squared from 0 to 4 is pi over 2, 16 minus nothing, because 4 squared 16, 0 squared 0. Half of 16, I hope, is still 8, but don't forget the pi like Mr. Isaac. And we have 8 pi cubic units. Okay, now let's go take a look. And we've redone. Okay, now the interesting one, which is new, because this is a non-trivial line. We're going to take this region, and now we're going to revolve it around the line y equals 4. That's the cool one. All right. Hey, so how does this look? Well, let's just draw this and make this bigger here. Okay, now, if remember, I'm going to, because that's the line y equals 4, and that's my line of rotation. So I want you to do the same process. You sketch the area like you're reflecting it over. It doesn't have to be perfect, it's just there. Remember, you only stick with your fundamental region. So in my fundamental region, okay, now you can see that cross sections are still disk. But now this is where they get students all the time. Mr. Isaac, how do I find the radius? Well, I'm cutting it next. The radius isn't so bad because you just go back to geometry. The distance from the line y equals 4 to the x-axis, just drop a line segment. It's always 4. Now you look at this sample point right here. That's an x and a y value. My radius is right there, so I'm going to come over here. I put my radius there. Out of these points, which point represents the distance from the ordered pair to the x-axis? And that's y. Now you have two non-overlapping segments whose length is 4. So radius plus y is 4. But I don't want radius plus y. I just want the radius. So that's 4 minus y. But what is y? Y is x squared. So the area of this cross section is pi y squared, which is pi 4 minus x squared squared, which is, now I'm going to do some algebra. I think 4 times 4 is 16. 4 times minus x squared is minus 4x squared doubled is minus 8x squared. And x squared times itself better be x to the 4th. Okay. So the volume of this slice, or the volume of this wedge, is the area of this cross section times dx. Okay. So this is pi 16 minus 8x squared plus x to the 4th in x. Now I'm going to stop this for a second. I'm going to pause this, and I'm going to restart Maple. Okay, so here we are. And I'm going to come up here to education. And, oh, it's blocking it, this little menu. So I'm going to go to calculus, volume of revolution. And I better open up a new spreadsheet too while I do that, because I don't want to mess this up. Okay. Now, this is y equals x squared. And the top line was y equals 4. We went from 0 to 2. I want a disk, a horizontal line, but the horizontal line is y is 4. Now, I'm going to go from 0 to 2. Let's use left endpoints. I'm going to hit animation. Okay, now notice when we're done, we're going to have 256 pi over 15 cubic units. Now I'm going to close this for a second because now it's bigger. Now when I click on this, I can come up here and I can, now can you see, there's my washer. So can you see that nice radius emulating from the line y equals 4? I can even turn this, see, so that doesn't help too much. But now can you see, if I turn it that way, you get a nice washer. Okay. Now we know it's 256 pi, but we're going to go and actually do it. All right, so here we go. So what's my volume? Well, that's going to be pi times the integral from 0 to 2. And now I'm just going to go and 16 minus 8x squared. Don't forget to add a little plus x to the 4th in x. All right, so this antiderivative is 16x minus 8/3 x cubed plus 1/5 x to the 5th. We're going to go from 0 to 2. Now, at 0, these are a bunch of zeros. So we really, we're just going to have a 0 there. So this is pi, but the interesting part happens at 2. Is 16 times 2 still 32? 2 cubed is 8. 8 times 8 is 64. Okay, but I'm not going to do any arithmetic to start, because watch this. And 2 to the 5th is that 32 fifths minus, and we have a bunch of zeros. Okay. Now, guys, use arithmetic to help you. Now, what's going to help you in arithmetic is factoring, because 32 is a factor of all these numerators, so I'm just going to factor it out for a second. So that's a 1 minus, that'll be 2/3. Now look, does that make everything smaller? Hey, look right here. So you should remember that 2/3 plus a 5th. Okay, so we're going to multiply this by 5 over 5. So that's minus 10/15. And this is going to be 3 times 5 is 15. Now, remember, 1 is 15 over 15. Okay, so 15 minus 10 is 5. 5 plus 3 is 8. So this is 32 times 8/15 pi. 240 and 16 is 256. Don't forget the 15 pi cubic units, and we just verified what Maple told us it was going to be. But wait, I want to do something else with you here. So we're going to talk about this in class tomorrow, so pay close attention. Let me get Maple back up and running. I'm going to come back up here, and I'm going to go back to the volume, and I'm going to come over here, and we're going to take the same problem. But this time, what we're going to do, young adults, is instead of using the line y equals 4, how about the line y equals 7? So we have a hole. We're going to have a hole in our solid. And now let's do the midpoint sum. And let's just do, I just want you to see that this is a hole. And we'll do 10 of these. Okay. I want disk. So I want to animate this. Okay. So we're going to have a holy solid, so to speak. Ha ha ha. Okay. Now notice, can you see the physical hole right there? So I'm going to, okay. So wait, Mr. Isaac, you just, wait 1 second. So, I'm just going to set this one up. And then we're just going to set this up tonight. Because I want to tell you, this is not bad. Okay, this is not bad. This process, if you learn the process, it takes care of itself. And we'll come back to that in a second. Okay. So Mr. Isaac, wait. So you sketch. Okay, now we know that this is y equals 4. So y equals 7 is about here. I don't care. Don't make it perfect. Okay. Now we're going to say if I reflected that, it would look something like a Pac-Man, right? So that image would be here. Now can you see that I have a disk and I take away another disk? They call this the washer method, but I'm like, hey, man, don't psych yourself out. Huh. Okay. So it's like we have a donut, kind of like, but it's not really a donut. We're still integrating in X. We have 2 radii. We have a big radius and we have a little radius. Hey, but notice, drop that. This is always 7. Now, if you think about this distance over here, we're going to do the little radius first. This distance is always 4, so that's the little radius. So little radius plus 4 is 7, therefore the little radius is 3. That wasn't so bad, now was it? But what about big radius, Mr. Isaac? Oh, wait 1 second. Oh, okay, keep this down. This whole distance is still 7. Now, we'll take this point right here. That's an X and a Y. Like we did before, we come over here. There's Y, and there's big R. So big R plus Y is 7. So big R is 7 minus Y, which is 7 minus X squared. Oh, okay. So the area of my cross-section is pi big R squared minus little r squared. So this is pi, big R squared. 7 minus X squared minus 3 squared. Oh, okay. Okay, this is pi 49 minus 14x squared plus x to the 4th minus 9. Oh, 49 minus 9, I hope that's still 40. Minus 14x squared plus x to the 4th. And then you should notice that Mr. Isaac dropped his pi. So the volume of this solid is pi, the integral from 0 to 2. And now I'm going to plagiarize my trinomial. That's of degree 4, right? And don't forget to write the squared down because I did that earlier today. And whoop, that really made it a wrong problem. Now, that will give you the volume of that solid. Boom! Shakalaka. Oh, but wait. There's one other thing I want to do. When I want to go back and revisit something for a second. Okay. So delta x, we had 10 of these, right? So that would be 2 minus 0 over 10. That's a fifth. So this is pi. We're going to go from n equals 1 to, or I equals 1, not n, to 10, because we had 10 of these, right? Okay. Now, if you think about this, this is going to be x sub I to the 4th minus 8x sub I plus 16, all times, okay, well, we did 1/5. And x sub I is going to be 0, plus, since it was a left endpoint method, I minus 1 times 1/5. Dun, 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 dun. But Mr. Isaac, we don't have an n. Yes, we do. We knew n was 10. That's why you're seeing 5s. So there you go. We did more than I asked for.